Parameter space and t-values. In science, a parameter space is the set of all combinations of values for all the different parameters contained in a particular mathematical model. In this context, we will consider the internal geometric space of three different GC types: a line, a curve, and a surface. The t-value is a method of defining or locating any point value on that line, curve, or surface. So for example, if we define the space of a line as the extent of the line, so that the line is one unit regardless of its actual dimension, then the t-value is a position on the line relative to the entire line. So that when the t-value is 0, that is the start point of the line. When the t-value is 1, that is the end point of the line. And when the t-value is 0.5, that is the midpoint of the line. A t-value of 0.35 would be 35% between the start point and the end point. B-spline curves are similar, but do behave a little differently. If we define the space of a curve as the extent of the curve, so that the curve is one unit, regardless of its actual dimension, then the t-value is a position on the curve relative to the entire curve. But t-values do behave differently on curves, so that when the t-value is 0, that is the start point of the curve. When the t-value is 1, that is the end point of the curve. And when the t-value is 0.5, that is the midpoint of the curve as defined by the tightness of the curve. Without going into the mathematics of how B-spline curves are constructed, think of it this way. If you were faceting the curve with glass panels, for instance, where the curve is tighter, you would want the facets to be smaller, and where the curve was less tight, you could have larger facets. So the points are closer together on tighter parts of the curve, and further apart on less tight portions of the curve. Now, B-spline surfaces are actually two-dimensional spaces with parametrization of one unit in each dimension, named u and v. Therefore, in order to locate a point on the surface, both a u value and a v value are required. These values would fall in a range between 0 and 1, and on a B-spline surface, their spacing would behave the same as on a B-spline curve. So let's take a look. We will place a point along this curve using a t-value, and then control its location by changing the t-value. So we'll start by using our Place Point tool, but as we place the point, we'll hold the Control key and hover over our curve. That will lock our point onto the curve. So as we place the point, it is locked to the curve. You can see we have a node on the graph, 0.06. Its technique is by parameter along curve. It's using the B-spline curve, and it also has a t-value, which right now is 0.38. And if we select the handle, notice the handle is restricting you to move the point along the curve. That will modify the t-value anywhere between 0 and 1. Now we could actually type in a t-value if we want to be more exacting. So for instance, we could put in a value of 0.5, and that would move the point to the midpoint of the curve. If we put in a value of 1, that would move the point to the end of the curve. Or 0.75 would move the point to about 3/4 of the curve. And that's how you place a t-value on a line, curve, or surface in generative components. Thank you.